Welcome back. So we're going to look at the last video on solving equations, and this one is on solving quadratics containing algebraic fractions. The hint here is to combine the algebraic fractions or to remove the denominators. In this case, I'm going to remove the denominators by multiplying everything by 4 and then multiplying everything by 3. I'm going to multiply this numerator by 4, I'm going to multiply this numerator by 4, and I will multiply the other side by 4. Now I'll do exactly the same with multiplying everything by 3. Now if you look closely, we can actually start to cancel. So in this case, we can cancel the 4, and in this case, we can cancel the 3. And if you rewrite this, we end up with this equation here. Now all we do is expand and solve. So again, firsts, then outsides. Same here, remembering that that is a positive 4. Firsts, then outsides. Collect like terms and rearrange for x. So in this case, we're going to subtract 23 from both sides. And now we get x on its own by dividing both sides by 7. So those 7s would cancel. And that is your solution. In this particular case, it's a very straightforward solve. Let's have a look at a more challenging one. So on the previous example, I removed the denominator. And on this example, I'm going to combine the fractions. And what I mean by that is I'm going to have a common denominator here. So my denominator will want to be x plus 2, x plus 3. So I've brought the equation down. So the first thing I need to do is make a common denominator. And to do that, I multiply the one fraction by x plus 3 over x plus 3 and the other fraction by x plus 2 over x plus 2. That is the same as multiplying both of these by 1. So there's no need to do the same over this side here. So in doing that, I end up with the same denominator for both of these fractions. So I can rewrite that. And now I can get rid of this denominator by multiplying both the numerator here and the number 1 over here by x plus 2 multiplied by x plus 3. I would now get the numerator on this side left as it was, and over here 1 multiplied by x plus 2 all multiplied by x plus 3. In this case, we don't really need the 1 there. Okay, so all we do now is we expand and we solve. So I expand the first bit. We've got 5x plus 15 minus 6x minus 12, remembering that you are multiplying that by each of those components. And then we use FOIL to expand this. X squared plus 3x plus 2x plus 6. Now we collect like terms on both sides. So 5x minus 6x is minus x. 15 minus 12 is plus 3. 3 plus 2 is 5. I want to make this side equal 0. Remember, we're making this a quadratic equaling 0. Add x to both sides, that becomes 6x. Take 3 from both sides, that becomes plus 3. So we now have x squared plus 6x plus 3 equals 0. This bit's the key, so don't forget that. You're trying to make it equal 0 so you can solve this. You might notice when we find the factors of 3 that they don't add to give us 6. We can't factorise that in the usual way. So we're either going to look at factorising by completing the square or using the formula. In this case, I'll factorise by completing the square. So here goes. I'm only looking at this section here. So let's do that up here. So we know there's a bracket with x in it. We have half of the value of b. So that is plus 3. That's all squared. And we subtract half the value of b squared. Well, 3 squared is 9. Don't forget the plus 3 equals 0. Let's start to neaten this up. Well, minus 9 plus 3 is minus 6. And to get rid of minus 6 from this side, we add 6 to this side, and we have to then balance the equation by adding it to this side. So we end up with x plus 3 squared is equal to 6. Now we square root this to get rid of the all squared there. Right, before we go too far, we must remember the answer to a square root has 2 solutions. So we mustn't forget to put the plus minus there. And now we subtract 3 from both sides, and that there is our solution. In fact, it's 2 solutions. So we have x is equal to minus 3 plus the square root of 6, or x is equal to minus 3 minus the square root of 6. So in this case, we have found a common denominator. We couldn't factorise in the usual way. We factorised by completing the square, and then we have both of our solutions. Let's have a look at one more. What I'm going to do, I'm going to multiply each term by this and then multiply each term by this. So I'm multiplying 8 by both of those terms, I'm multiplying 1 by both of those terms, and I'm multiplying 2 by both of those terms. If I do that, I would be able to cancel the 2x plus 1 on this side, cancel the 3x minus 5 on this side, and I will end up with 8 in brackets 3x minus 5 plus 1 bracket 2x plus 1, and that is equal to 2, all multiplied by 2x plus 1, all multiplied by 3x minus 5. And now what we do is we just expand brackets and neaten that up. So remember, we're looking at FOIL again. So we multiply the first and the outside, remembering again that that is a positive 1. In this case, I would multiply this bracket, get a new bracket, and then multiply it by that one. So let's just do the first one using FOIL. So as you can see, I've expanded the top bracket here, but not the second one. So I need to now use FOIL to expand these brackets, and I need to collect these terms together. So I've expanded that. I get 12x squared minus 20x plus 6x minus 10. So now I need to collect these like terms as well. So like before, I need to make one side equals 0. So my aim is to get ax squared plus bx plus c equals 0, remembering that that is ax squared plus bx plus c equals 0. That's what I'm trying to achieve. So I subtract 26x from both sides and I add 39 to both sides. And I'll get 12x squared minus 40x plus 29 is equal to 0. Now in this particular case, if I divided everything by 12, I would get some awkward fractions here, so I'm not going to make that a coefficient of 1 in order to factorise or in order to complete the square. So I'm not factorising this equation here. What I'm going to have to do is use the formula. So at this point, this is where you need to remember your formula. So here we go. Here's the quadratic equation, and there is the quadratic formula. So this is a matter of substitution now. We need to know the value of a, the value of b, and the value of c. Well, a is 12, b is minus 40, and c is 29. So all we do now is take those and replace the letters in here for those values, and we solve it. So we start with minus b. Well, b is minus 40. So don't forget you get minus b. All of b is actually minus 40. Plus or minus the square root of b, which again was minus 40 squared, minus 4 multiplied by a, which is 12, multiplied by c, which is 29. All of that square rooted, all divided by 2 lots of a. Well, 2 12s are 24. So therefore, x is equal to 40, because two negatives make a positive in this case, plus or minus the square root of 208, all divided by 24. Now we have two choices here. We can put that in our calculator and get a number, or we can simplify this by dividing everything by 4. Remember, in this case, you're dividing by 4 and then dividing by 4 again, because that is being square rooted. Therefore, x is equal to 10 plus or minus the square root of 13, all divided by 6. They are our solutions. There are two solutions there. It is 10 plus the square root of 13 divided by 6, and it is 10 minus the square root of 13 divided by 6. So there we go, solving quadratics containing algebraic fractions. Hopefully that's been helpful, so please like and subscribe. And you have now completed all 7 videos on solving equations. Well done, good effort.